Hello, my name is Aditya Pratap Singh and my roll number is 200108070. And today I am discussing an interesting problem on the probability. So first of all, we need to discuss the theorem which we will use in the question. So here the theorem is, if x is a continuous random variable with the probability density function f of x, then for any real valued function g, the expected value of a discrete random variable gx is defined as following. Expected value of g of x is equals to integration of g of x fx dx. The limit goes from minus infinite to plus infinite. So here the information about the question is given. Suppose that we have an appointment with someone, and if we are s minutes early for an appointment, then we will have to incur the cost cs, and if we are s minutes late for the appointment, then we will have to incur the cost ks. And suppose also that the travel time from where we presently are to the location of our appointment is a continuous random variable having probability density function f. So given the current situation, we will have to determine the time at which we should depart if we want to minimize our expected cost. So here I have discussed the problem in my own words. Let x denotes the travel time and we leave t minutes before our appointment. In this way, we have t minutes time to reach our appointment, and if t is greater than x, then we will reach there t minus x minutes early. So we will have to incur c multiplied by t minus x, and if t is less than x, then we will reach there x minus t minutes late. So we will have to incur k multiplied by x minus t. And suppose our cost is pt, then the function of the t is given below. And if x is less than t, then we will have to incur c multiplied by t minus x. If x equals to t, then we will have to not incur anything. And if x is greater than t, then we will have to incur k multiplied by x minus t. So in this question, we will have to calculate the minimum expected cost. But first, we will have to find the expected cost function. So as we have discussed earlier, if x is the random variable with the function f, then the expected cost value of the function gx is given by this equation. And here in the question, the travel time x is the random variable which has the function fx, and the expected cost also depends on the travel time. So we can use this equation's help, and with the help of this equation we can write the expected cost function something like this. And here we have broken this integration into the two parts. The first part defines when we reach the early, and the second part describes when we reach late. And we have simplified this equation here. And to minimize the expected cost, you will have to find the minimum value of the expected cost function, and you will have to differentiate the expected cost function. So to differentiate the above equation, we will have to take the help of the Leibniz theorem and the multiplication rule of the differentiation, which we have learned in the 12th standard, and both of the formulas are mentioned here. So here we need to differentiate this equation. And to differentiate these equations, first term we will take the help of the Leibniz theorem and the multiplication rule. To differentiate the second term, we will take the help of the Leibniz theorem. To differentiate the third term, we will take the help of the Leibniz theorem. To differentiate the fourth term, we will take the help of the Leibniz theorem and the multiplication rule. So after differentiate this equation, we are getting expected values cost differentiation equation something like this. And we will also know that the total area of the probability function equals to 1. So here integration 0 to integration t to infinite f of x dx equals to 1 minus integration 0 to t f of x dx. And here, instead of writing everywhere 0 to t integration f of x dx, I am writing it is equals to capital F of t. And after replacing all the variables in this equation, I am getting this equation. And after simplifying this equation, I am getting expected values differentiation equals to k plus c multiplied by f of t minus k. And for the point of the minima, we need to make expected cost differentiation equals to 0. So we assume that the t star is the point of the minima. And after putting expected values differentiation equals to 0, I am getting capital F of t star equals to minus k upon k plus c. So minimum cost is obtained when we leave t star minutes before our appointment, where t star satisfy the following equation. Capital F of t star equals to minus k upon k plus c. And again replacing f of t by integration 0 to t f of x dx, I am getting f of x dx integration 0 to t star equals to minus k upon k plus c. So this is our final answer, and thank you.